Elephant toothpaste is made from hydrogen peroxide and sodium iodate. The sodium iodate reacts with the hydrogen peroxide by removing an oxygen atom, which produces water and oxygen gas. Adding yeast with the hydrogen peroxide will quickly break down the water and oxygen gas, and adding dish soap provides additional surface tension, which allows the bubbles to get trapped and creates a lot of foam. So we started off by mixing yeast with water and added soap and gave it a good stir. Next, in a separate container, we added food coloring to 3% hydrogen peroxide to make the elephant toothpaste red and blue, but ended up mixing to become purple because we didn't really separate it that well. So our expectation for the elephant toothpaste was that it was going to explode outward in this huge pile of foam, kind of like the videos that Mrs. Catania showed us, but in reality, it kind of just foamed up a little bit and then it went down. It wasn't explosive at all and just left us a little bit disappointed. On our second attempt, we added more hydrogen peroxide and about the same amount of yeast, and as well as adding green dye. And this attempt fell out even worse than the first time, just because the elephant toothpaste really reacted really slowly and it didn't really do as much as the first time per se, and definitely not as much as we wanted it to do. In our final attempt, we added the rest of the hydrogen peroxide, which was a little less than half the bottle, with the remaining amount of yeast that we had. We decided to dye it pink, and I feel like this one was the best experiment that we had so far, just because the reaction was a little bit faster. It definitely wasn't as explosive and as big as we wanted it to be, but compared to the first two, it's definitely an improvement. And to conclude on the elephant toothpaste experiment, the reason that it didn't have a bigger reaction was because we didn't have enough concentration of hydrogen peroxide. We only had 3%, and if we had something like 30% hydrogen peroxide, it probably would have exploded more and done more cool things like the video showed us. But at least we had fun playing in it. Light is emitted when the energy from the electron is transferred to a proton. Ions of metals and nonmetals turn flames into different colors because when heated, the atoms move in an excited, unstable state. When they return to their stable state, the excess energy is released in the form of light, which is characterized by the colors we see. Since varied wavelengths correspond to their own individual colors, its result is the emission of different colored lights. Depending on what molecule is undergoing combustion, the electron energy state changes. Thus, the combustion of different substances produce different colored lights. For our fire lab, Will bought packets of fire dyeing powder that contained copper sulfite, and as you can see, when we added the packet, it immediately turned a mix of green, blue, purple, and a reddish orange. On our second attempt, we added the remaining 2 packets, and to show our love of chemistry, we said this.
3, 2, 1, chemistry!
And I was unfortunately standing the way that the wind was blowing, so when we put the packets in, the powder pretty much flew directly into my nose and into my lungs, which was not fun. So even though I inhaled copper sulfite, I feel like this experiment was pretty successful overall, just because we were able to turn the fire into these different colors, which I thought was really cool. And it was also kind of nice understanding the chemistry behind that and how that all kind of worked. And yeah, that's pretty much it. Thanks for watching our video, and don't forget to smile.